Hey guys, it's the Techie Biochemist here, and today I'm coming at you with a tutorial on how to run a simulation on your own protein with NAMD and VMD from start to finish. So the start point we're going to hit is finding a protein with the or in the protein data bank. So we're going to say RSCP PDB. That's going to bring us to the RSCPD homepage. Now here you can type in anything you want. I'm going to go, the protein I'm going to be working with is hirudin. Specifically, I'm going to go with this one because I know it'll work because I've actually already done all this and I'm just redoing it for this tutorial. So what I'm going to do is once I've opened this up, I'm going to download it in PDB format. And if I show this in my downloads folder, there it is. And I'm going to drop that over into tutorial. And within my tutorial folder, actually, I keep all of my PDBs neatly in here. So that's where it's going to be. Now we're going to open up VMD. And so what I'm going to do is I'm going to say open new molecule for here. Load that up. And now I can see it here, and I can see that yes, it is a happy little protein. And so the first thing I'm going to do, because I want to make this simulation as easy as possible, is I'm going to come in here to TK console and say set to atom select top all. And then I'm going to say measure center $ for here. And that's going to tell me where the center of this protein is currently. It's pretty close to 0, but not quite, so I'm just going to move it a little bit closer. I believe the command for that is for here. Move by. I'm going to type in as many digits here as I can just to ensure that I get this thing as close to 0 as possible. And now if I run that measure center command again, now I'm still getting numbers, but they are to the power of -8. So in all practical purposes, or for all practical purposes, this protein is completely centered. So I'll go ahead and close out TK console for now. Now I'm going to come, I'm going to minimize that so it's out of my way. I'm going to come over here to modeling and hit automatic PSF builder. Now I do not want to use these files. Instead, I'm going to go through, delete all of them. And I'm going to use this INP file from NAMD 11 build in the NAMD tutorial files directory. Gonna load that. I'm gonna say I only want the protein because if there's anything else in this, that's not gonna be relevant to me here. Create chains and apply patches and finish. Now I'm going to close these out just so that I'm not getting any confusion with what files I'm working with. And I'm going to open up those files I just made. They're here in my folder. You can see PDB. I'm going to open that one first. And then on top of it, I'm going to open the matching PSF. Now it's important that these do match. And you'll see the way I'm loading the PSF on top of the PDB is it says load files for. So instead of new molecule, I've got it actually selected the PDB that I just loaded up. Now you didn't see any difference, but that PSF is loaded now. It's good that we didn't see any difference. If we saw any random weird lines appear, that would mean that we've got a problem. But in this case, it is a clean PSF, so we move on to our next step, which is going to be adding a salvation box. I'm just going to make sure that this is specifying the right one, and it sure is. Since we just loaded those in with nothing else, there's really nothing for this to confuse. And with use molecule dimensions check, that should be all I need to do. So now I'm just going to hit solvate. And there we go. Easy peasy, this protein is now surrounded by water molecules. And we've got a solvate PSF loaded in there with the PBB inside of it. If we come in here, we actually see solvate, PDB, and PSF. Rather than renaming those, I'm just going to instead show you here. If we put our output to solve underscore for here, it's just going to generate the same file, but now with that name instead of the name solvate, which is pretty generic. So you can see it's totally identical, but now it has a more specific name, and that is all I need to do in VMD. So the one thing I will do here is I'm going to come in here and just delete these two solvate files just to avoid having unnecessary confusion. And actually I'm going to go through and also get rid of all of those files. Basically, if it's not directly needed, I'm getting rid of it. That's just like a log file. Now I'm going to move my solvated PDB and PSF into NAMD, where I'm going to be working with them. And here they are. So now the next thing I need to do is make a duplicate of this UBQ underscore WS for water sphere, EQ for equilibration. And I'm just going to copy it over, Control C, come over here to NAMD, Control V. So now I have a copy of this file. I'm going to rename it for here, water sphere, EQ. And now I am going to open this up. So I'm going to change, this stuff won't read quite the same as yours if you're working with the absolute default file. But I'm just going to change it to refer specifically to my my file, which is solve for here, and same below, solve underscore for here. And I'm going to put for here underscore WS underscore EQ. That's the name that will be on the files that are generated now. And just going to take off one dot so it knows where to find that properly. This is all just file navigation. If this doesn't make sense, let me know in the comments and I'll do another video talking about file navigation on Windows. Now the next thing I need to do, and this is important, is setting the spherical boundary stuff. So this is all by default made for the Ubiquitin file that comes with the NAMD tutorial. Right now, this line here is referring to the center of the protein. I know that it is at 0, 0, 0 because that's what we did in VMD. We made sure that the protein was centered at the origin. This is the radius of the protein. I know from some work I did with PyMol, hyperlink to a video where I cover using the PyMol measurement wizard to figure out the dimensions of your protein, but I did that separately, and I already know that for this protein, it's about, the radius is like a maximum of 30 angstroms. Even that's a little bit generous. I could probably say 25, but I'm just going to say 30. This is the force applied to any atoms that jump outside of that spherical boundary, and that's like the exponent of the force. For minimization, I'm setting 300 minimization steps instead of 100. That just kind of helps prevent errors by kind of making sure that everything's packed in properly before you start running, and 2,500 steps is fine with me. So yeah, I'll leave it at that. Now, the next thing we got to change is this MSM grid spacing thing. MSM grid needs to be bigger than your spherical boundary. If my spherical boundary is 30, that's radius, so 30 angstroms from the center in any direction, these numbers need to be a little bigger than that. So I'm going to set all of them to 40, and that should be sufficient. You want all of your minimums to be negative and your maximums to be positive. That's pretty self-explanatory. And with that, this file should be properly configured for this protein run. So I'm going to go ahead and close it out, save my changes, and now I'm going to open up the command prompt. So what I'm going to do is I'm going to first navigate to my NAMD folder within tutorial. So cd tutorial /NAMD, and now I'm going to type in NAMD2 and type in the name of my configuration file, which is for here underscore EQ. Then I'm going to type a greater than sign because I want this to create a log file. So that'll be the name of the log file generated, and then I finish the command with an ampersand and hit enter. Able to access config file. Fricking why not? Did I type the name in wrong? Oh, that's fine. I do need to type the entire name of the file in, and I left off the file name end. So now it should work. And this should be my log file. Yep, if I open it up, it is being written. Since I'm opening in Notepad, I won't see those changes, so I just kind of got to wait till this is over, but I can just periodically open it up and see changes in the file. Okay, it's around step 50 max, so I just kind of got to let that do its thing for a while. Actually, I'm going to pause this recording while this does its thing so I'm not overtaxing my computer, and I'll see you in a minute. All right, guys, well, it's a few minutes later, but the simulation has finished and I'm back. So let's go, and just to show you that it's all done, here's the log file, and if I come down to the very bottom, we got to the last step, which was step 2800. The reason why it's 2800 instead of 2500 is because I did 300 minimization steps. So this is the sum of minimization and actual run steps. That's the right number. And finally, we get kind of this, essentially this whole section that says like closing, coordinate, DCD file, and then the wall clock and CPU stuff. That's just kind of your end of file that you can expect on your log files. So now that we've done that, we can go ahead and close out because we are done with NAMD for now. Now we're going to come back into VMD and actually load up our simulation. So for new molecule, we're going to browse into NAMD. First, we're going to open up the PDB and PSF, starting with the PDB that we used to make this in the first place. Load the PSF on top of that. And now we're going to load our DCD file on top of all that as well. Whoops, just need to hit load here. Okay, and now you can see we have 11 minimization steps that we can play through. I'm going to decrease the speed so it doesn't go absolutely nuts and minimize this in the background since we don't really need to see that. But yeah, now we can see the protein wiggling. So to make it a little bit clearer and get a better look at what's actually happening here, I can change around the representation. I'm going to put the protein on surface. And just say color ID We'll put it on green so it's nice and visible. And then I'm going to create an additional rep. This time I'm going to put it on VDW, and I'm going to say water. And for these, we'll just put names so it's clear they're water, and I'll decrease the sphere size to about 0.5 so we can kind of see stuff properly. And with that, I'll go ahead and play it, and now we can see really how the protein moves around in water. So there you go. You've now, if you followed this tutorial successfully, you've now run a start to finish simulation on your own protein file in VMD and NAMD. I hope this tutorial was helpful for you. If you ran into any errors or have any questions, hit me with them in the comments and let me know what you'd like me to cover in future videos. Give this video a thumbs up if you found it helpful, and subscribe so that you get those notifications for further videos. And hope you have a great time with all of your simulation aspirations and whatnot.